So let's look at some forms of carbon. So diamond is a form of carbon, and another word for form, when you're talking about carbon, is an allotrope. So diamond has the following properties. Each carbon atom in diamond is bonded to 4 other carbon atoms by strong covalent bonds, and this creates what we call a giant covalent structure. There's a lot of energy needed to break those strong covalent bonds, and because there's so many strong covalent bonds, it means that diamond has a very high melting point. Diamond also doesn't conduct electricity because there aren't any delocalized electrons in the diamond structure. And it's also very hard, so there's lots of strong covalent bonds in diamond, which makes it very, very hard. And it's so hard that it's sometimes used as like a cutting tool to cut through other materials. So let's recap some of that. So diamond cannot conduct electricity because there are no delocalized electrons in the structure. And some of the structures of diamonds there are carbon atoms, and each carbon atom connects to 4 other carbon atoms, and between them they connect by covalent bonds. Graphite is another allotrope of carbon. Remember, allotrope just means form. So graphite has the following properties. So each carbon atom in graphite is bonded to 3 other carbon atoms by strong covalent bonds again. Now this creates a giant covalent structure. And graphite is quite soft because it forms layers of hexagonal rings. Hexagonal just means 6-sided, where each layer is held together by weak intermolecular forces. And those layers can slide over each other quite easily. So graphite is very soft, and this makes it useful as a lubricant and also in the pencil lead. Graphite also conducts electricity. So because each carbon atom only bonds to 3 other carbon atoms, that means that 1 electron from every carbon atom in the graphite is delocalized in the structure. And this electron can move freely, so graphite can conduct electricity. So to recap that, graphite is one of several allotropes of carbon. The weak intermolecular forces in graphite make the layers slide over each other easily. And for each carbon atom, there is 1 delocalized electron, which allows charge to flow and gives rise to its role as an electrical conductor. So, graphite is an allotrope of carbon. It's made of hexagonal rings. It's an electrical conductor, and it is soft. And the properties of diamond, to recap that, it's got a very high melting point due to those strong covalent bonds. It contains, as I mentioned, covalent bonds. It does not conduct electricity because it does not have any delocalized electrons, and it's a very hard substance, and it's sometimes used for cutting. So remember, diamond, it does not conduct electricity, and 1 electron from each atom is delocalized in graphite. How many carbon atoms is each carbon atom in graphite bonded to? Now remember, in graphite you've got 1 delocalized electron, and each carbon is connected to 3 other carbons.